Hello, F Sharp. How are you doing? So I had another interesting question where I need to remove elements from sets. And one of the things that I wanted to investigate is what is the best type representation that I can use that's going to give me the most speed. And there's several different ways I could model it. So I wanted to try those out and see, okay, which one of these is going to be the fastest for the scenario that I'm working on. So I wanted to walk you through that process of doing that. And right now what I do is I have an empty directory. Let's go ls, and there's nothing in here. So what I'm going to do is I'm going to create a new benchmark project in F Sharp and walk you through the process of creating the benchmarks and running the code to see, okay, well, which one is faster? I have an intuition, but I want to verify that. So what I'm going to do is say .NET new, I'm going to use console app, and I want the language to be F Sharp. And from there, once I add that create that project, I need to .NET add package benchmark.net. So adding the benchmark.net library to here. And so now we should be able to go in and create our tests. So code, opening up a VS Code in that directory. And let me go ahead and zoom in for you. So what you're seeing now is, let me go to the here. ND project, single file in there. There's one other thing I'm going to add here, and that is the platform. Because in my case, I only work in x64. And it's just because of the types of work that I do in the libraries that I need to use. And so I'm only really concerned about what the performance would look like targeting x64. Benchmark.net has been added. So I'm going to come over here to program.fs. And so we got a blank project here, just got the simple hello world. So first thing I'm going to do is say, I want to create an entry point here. So entry point. Let main args equal, and that has to return an int. I'm going to say just return 0. And the reason I need to do this is because later I'm going to have some code that calls my benchmarks, but so we will come back to this. Next thing I do is I'm going to say, hey, open benchmark.net, and I'm going to need attributes, and I'm going to need benchmark.net and running. So that should cover most everything I need. I'm going to go ahead and open system as well. I almost always need it, so I'm just going to preempt that. And now I'm going to create a class, which is going to hold my benchmarks. So type, and I always call it just benchmarks, just because I don't want to spend time thinking about something clever. And then I throw in a default benchmark just so that the compiler is happy and isn't shouting at me. I'm going to go ahead and zoom in a little bit more for you. And so first test is nothing. It's very exciting, but now the compiler is happy. And that's really what I was trying to do. And I can even go in here and say, hey, let benchmark runner run benchmarks. So, and I'm going to do one more thing. I'm going to annotate this with the attribute benchmark. So this is basically what I would kind of call the hello world of benchmarking in F Sharp. I have a class, which is meant to hold my benchmarks. I then have a main method, which calls benchmark.net's code. And I'm telling benchmark.net, like, hey, I want you to look at this class, look for all the members of that class, which have been annotated with the benchmark attribute, and I want you to run them as my benchmarks. So there you go. Hello world of benchmark.net and F Sharp. Now, my question is, I need to be able to remove an item from a set. I want it to be really fast. There's a lot of ways I could represent that. There's the most natural way of representing it if I was using like domain-driven design, but then there's other representations that potentially could be faster. And before I spend a bunch of time working on code, like, oh yeah, this is definitely going to make it faster, I like to go through and look at, hey, I can model it. I can model it this way. I can model it that way. I can model it this other way. And I like to understand what the performance implications are of those different representations before I spend a bunch of time going in and refactoring my simulation code. So that's what I'm doing here. There's just so many different things to look at. So we're looking at sets today, and there's a few different ways to do that. I could use raw integer, which is the simplest way to represent an item in a set. There's also units of measure, there's records, there's discriminated unions, and then versions of that. So I'm going to create some types that I'm going to use in these benchmarks. So first thing I'm going to do is I'm going to find a unit of measure. I'm going to call it, just call it job. For the domain I work in, I'm usually trying to create simulations of manufacturing facilities. And so the idea of a job, a work order, machines is ubiquitous. And so I am creating a unit of measure of job. And so the idea is I could take an integer, I could annotate it and say like, hey, this isn't just an int. This int is meant to represent a job. I'm actually going to call it job ID to be more descriptive. So I am now adding information to an int. Well, there's a few other ways I could represent that. So I could have a record job ID, which is, hey, this has a value and it's an int. And so I could say, hey, I'm going to represent job IDs as records. Cool. And again, I'm just looking at a bunch of different possible representations. I'm not saying which one's correct. I'm just curious about the performance implications of them. Another one could be the exact same thing. So struct record job ID. My apologies. My typing accuracy just falls apart when I'm recording and talking at the same time. My brain cannot do both. So why are you angry? What? Type structure record ID. This shouldn't be a problem. Okay. Stuck. Okay. Yeah, there's no stuck attribute in F#. Struct. So the difference between these is that this is a reference type. This is a value type. And maybe in the future, I'll do a video where I kind of go into a deeper dive about this. If you want to know more about that, I highly recommend pro.net.
Hello, F#, how you doing?
Management. So I had an interesting question that I wanted. So if you want to know more about that, I highly recommend checking out pro.net memory management, because it really goes into a deep dive of understanding what the implications of reference types versus value types. But that's essentially what I'm doing here. Another way I could represent this is with a discriminated union. That's really common. So, okay, I could say du job ID, and I could say job ID of int. So single case discriminated union. I could also have a struct discriminated union. Struct du job ID. I'm just going to again say job ID of int. So I'm going to try int. I'm going to try an int that has been annotated with a unit of measure. I'm going to try a record, a struct record, a du, and a struct du as different ways of representing this information. And I want to see, okay, how fast can I remove one of them from a set? And from there, I can then make a judgment call like, okay, what would be the best way for me to approach this problem? So first things first, I often have to generate random data. One of my first rules is create a random number generator and set a seed. This way I know I can generate the exact same values every single time. That's really important for me because I want to be able to reproduce what I'm doing. I just use 1, 2, 3 as the seed as a default, whatever. You can use whatever you want. Okay, now I need to create the data I'm going to do the tests on. And so I am going to, what I'm going to do is I'm going to create the sets. And then I am going to generate a set of values that I'm going to use to remove random values from the set. And the reason I'm going to do that is because I don't want one of my tests to randomly be removing a really advantageous element. And then, oh yeah, this looks like the best way to do that. And it's like, well, it wasn't actually because that is generally the best approach. It's because like your test only tested one value. Therefore, yeah, it looks really good, but it was only because like it was, the memory was laid out such that like, oh yeah, that one like just happened to work really well. So I want to create the different sets, generate a bunch of different values that I'm going to use for just eliminate values from those sets and seeing what the performance is like. So from here, I want to generate a set of values that I'm going to use for all the different types, but just different representations. So I'm going to say, hey, let value count. I'm going to say like, okay, I want 100 values. And I'm going to say, hey, let values equal, and I'm just going to be really lazy and say like, hey, 1 to 100. And so now I could have my int set. So let int set equal, I'm going to just say set of values. Again, my typing accuracy just dies when when trying to talk and record at the same time. So I got an int set. So sets for removing elements from. Cool. Now I need to create my int unit of measure set. So I'm going to call this unit of measure set. And I want to take those values and I want to annotate each of them with a unit of measure and then put them into a set. So I'm going to take values. I'm going to map them and say, hey, I'm using language primitives int with, I have 32-bit ints. I want to annotate them with a value. And I'm going to say, this is job ID. And I'm going to put them all into a set. So now those integers are no longer just naked ints or just naked primitives. I've added context to them saying like, hey, this int is meant to represent a job ID. It represents something in particular. Now, my intuition tells me, hey, the performance of these should be the same between these because the F-sharp compiler erases units of measure, so they should be the same. But the nice thing about units of measure is that we've enriched that primitive with additional information so we know what it's really meant to represent. So then we have our record set, and we need to do the same thing. We're going to take these values, we're now going to wrap them in a record and then put them in a set. And I could do this. I'm going to show you the way you can do it. And then I'm going to create something that's like a little cleaner. That's like the way I prefer to do it. List map. Ew. Record. Yeah. Value equals X. Okay. We can just go with it. This is fine. If I was, normally I wouldn't construct this way. If I was actually using this in a real domain, I would define something like a static member create I, and then say like, hey, value equals I, to make creating it a little cleaner, but we'll go with this for now. I'll do a different video at another point, which is like how to write nice, clean builders and stuff, but that's not the point of this. So some of this code won't look quite as elegant as I would like, but we're benchmarking. We're not writing, some amazing work. So we also have struct record set and values and list map on X. And again, struct record value equals X. So you might be saying, Matthew, I thought like with F# you could just do this and it would figure it out. Well, the reason I'm having to prefix it with the name of the record type is because the F# compiler is matching this structure against the last thing it observed in here that looks like this. And right now, struct record job ID is the first thing it finds that looks like this. That looks like this. But I don't want that. I want the record job ID type. So when I prefix it, I'm telling it like, okay, this is this record type. Okay, I also mean my DU. So DU set values. Oh, my apologies. My apologies. I forgot to put this into a set. And again, I'm going to do the same thing. List map function X. And then DU job ID X. Put that whole thing into a lovely set. Scroll down, give myself so struct DU job, no, struct DU set. Values list map that thing struct DU job ID X. Again, this is not the normal naming convention I would use. We are just benchmarking right now. So please don't judge me. Okay, so we got all the different sets that we're going to test against. We got our int set, a unit of measure set, record set, struct record set, DU set, struct DU set. But now we need to test values to remove. And in this case, I want a bunch of different values that I want to try removing from it. And I want to make sure that I'm removing the same thing from each of them, just using different representations. And so I'm going to say int removes. Is that what I want to call it? I'm going to call it int values. Int values. And I want these one in an array. And I'm going to say let remove count equal. I'm going to try removing just 10. And do 10 different removals. Let's go ahead and do 100. And the reason I'm doing this is sometimes I'll want to go back and like, okay, now I want to try 1,000, maybe 10,000. But for this case, in the domain I'm working in, really 10. 10 is the best for the domain I'm working in. And so I want to generate 10 random values that are going to be in this set and try removing them and seeing what the performance is going to be. So I don't care what the value is. So I'm going to say 1 to 10. And next, so I'm going to generate a random integer that I know is going to be in that set. And the upper bound on that is, okay, my apologies. I meant for this to be from 1 to value count. So I want to generate a random value in here in this range of values. So this is 1 to value count. I made my life a little bit harder because I went from 1 to value count. So here in this random number, I'm going to have to say like, hey, the bottom value is 100 and the top value is value count plus 1. The reason I'm having to add 1 here is because the next method is exclusive on the upper bound, but I want to include that as a possible thing for it to remove. So now I have 10 different int values that I'm going to try removing from these sets. But now I need the different representations of this. So unit of measure values equals, and I'm going to say int values, the exact same thing. And now I'm going to say array map and say language primitives int 32, and this is using the job ID. And now I need my record values. So record values. We're going to map the int values, array map. And we can use the exact same functions that we used up here. So I'm going to go ahead and copy that down. And struct record values. Again, I'm going to take int values. I'm going to map that. And I'm going to copy and paste this function from over here. Struct record. Yep, that's the function I want. And then I have my DU values. This is the exciting part of writing benchmarks. Yay. If someone knows like a really clever way of doing this quickly, please let me know. I'm not aware of it, clearly. Otherwise, I would be doing it. And then struct DU values, int values, array. This is going to be cool at the end, I think, maybe. Okay, now what we have is all the different representations of what is essentially the same data. I mean, it's all ints at the end of the day, but we've represented it in different ways to provide additional context really for us as the programmers. And now I want to see, okay, what's the performance going to be like of using these different forms of representing that? So I'm going to say this is my int test and say, hey, let mutable accumulator. I'm going to say this is result. I'm going to set empty, and the compiler is just going to figure out what result is supposed to be at the end of the day. And yep. So what I'm going to do is for each in int values do and result equals int set remove v. Okay, so let's talk about what this test is going to do. I'm creating this mutable because I'm trying to trick the CLR into doing work. And because in theory, what you could say is like, hey, this is only returning the last result that it observed, but I believe this is sufficient to actually have it do all the iterations to do the work. We have a set of 10 integer values. We're going to go through each of them, and we're going to remove that from the original int set, and we're going to return a new set. And we're going to do that 10 times. So for each of the int values in here, because there's only 10 in here. Each time, this is going to produce a new set with just one value removed. It's just each time we're removing a different value. And again, this is to remove any type of bias that we might be getting from, oh, we just happen to be removing a node that was in an ideal place for it. So by jumping around, we're making sure that we're measuring what the actual average performance of removing an element from the set would be. So now I'm going to do the unit of measure version of this. And so unit of measure values, unit of measure set. And I'm going to just do this for every single one of them to see what the performance is like for each. And so this one's going to be for record values, record set. Super exciting. Oh yeah. Struct record values, struct record set. You can see why I use the naming convention that I use, because it makes the copying and pasting very simple and repeatable. This is going to be DU, and this is going to be DU values and DU set. And last but not least, ye old struct DU. Struct DU values, yes. struct du set. Cool. So now we're going to test what the performance is like across every single one of these to see what it's like. And so from here, we're going to be able to take away what's going to be the fastest way of representing this information if we're using sets for doing the removal. So I'm going to say, hey, .NET run, and I want the configuration to be release. So we're actually benchmarking release code and not debug code. For those of you who don't know, the CLR, so the common language runtime, the thing that's taking your code and turning it into machine code, when it builds stuff for debug, that code has a lot of stuff inserted into it in order to make the debug experience in your IDE or whatever you're using easier. So it's like inserting instructions, and there are certain optimizations it won't perform when it's doing debug because it needs to be able to like stop at a moment and rebuild. Okay, this is what the stack looked like. This is what the heap looks like. So you can do some introspection and figure out what is going on. But when you build for release, you don't need to do that. And so it has all kinds of additional optimizations that it's going to do in order to get that code to run as fast as possible. So it is pointless to benchmark debug versions of code. You only ever want to benchmark release versions of code because that's where all of the optimization is actually in play. Unless, of course, you're deploying debug builds, but yikes, don't do that. If you're doing that, I know how to speed up your code. Build it for release. So this is going to take a little bit to run, and I'm just going to let that run. And I'm going to tell you a little bit about what my intuition was telling me about this. So I always think of integer as kind of my baseline of performance. I'm like, okay, how fast, if I used just raw arrays and I used integers, how fast could something go? And that is my, okay, this is what peak performance looks like in this scenario. The problem with that, though, is often there's a lot of effort involved in mapping the input down to that representation. Like I mentioned at the beginning, I'm typically dealing with things like, hey, I have a name for a job, I have machine names, I have facility names, and those things are all more naturally represented with strings or with more descriptive types. And one of the things I really like about F# is that it makes it really easy to define new types and therefore create a really elegant, succinct, complete representation of your domain that you're working in. And that's really valuable. And if I'm working on line of business apps, that is how I write code. When I'm in a performance scenario, though, different things come into play. And what I often end up doing is I end up often having what I call the modeling namespace. And that's the representation that is most natural for a business analyst or a domain expert. Like when they look at that version of the code, it makes sense to them. And so I have the modeling domain, but then I have the simulation representation or the engine domain. And in between those, there's a mapping that happens where I say, okay, I'm going to map from string, these beautiful representations that are very descriptive, down to just raw integers and arrays, because I know that that is the most sympathetic for how the CPU actually wants to work, and it will allow me to squeeze all the performance I can out of the code. But there's a lot of work that happens there, and sometimes it's not worth it. And it all comes down to how often does the code need to run? How valuable is a faster answer? And that always really depends. Where I get really excited about F# and performance is that And in the case of simulation of manufacturing facilities, if I can run the code, if I can run a simulation in an hour, that's useful. And I can look at, okay, what am I expecting to happen in the future for the day? But it doesn't let me run a bunch of different scenarios. And so you could think of like the speed of the code dictates the use cases for the code. So if it's slow, and say like taking us an hour, you can run it once and you can kind of get a general idea for what is going to happen if you're doing like a discrete event simulation. But if it only takes a minute to run the simulation, like, well, shoot, you know, I can run this thing multiple times and I can run it on several cores, and now I can start exploring different scenarios. So now you've gone from a high level view of what may happen to now you're exploring ideas. So now you have like an exploration use case. If you get that simulation down to seconds, like a single second, well, now you can start putting an optimization loop around that, saying like, oh, well, I'm going to try a bunch of different scenarios and take feedback from that and then adjust what my strategy is going to be. And now I can optimize how I'm actually running my facility. And what I love about F# is that we can start with the beautiful domain-driven domain modeling, which accurately represents the facility in this case, but actually it accurately represents what it is that you're trying to model. And then as necessary, you can, what I kind of call remove safeties, or it's like, okay, I need to go faster. I need to go faster. I need to go faster. F# doesn't get in your way when you do that. And that's where I talk about the modeling. I will try to do everything with just the modeling namespace initially. And then as I need to go faster, I will start adding like an engine layer, like I said, which has a faster representation of the original domain. But the bigger the difference between those two things, the more difficult, more complex that code becomes to map back and forth between. So this is why I'm like, ask questions like this, like, okay, if I'm going to use a set, is it worth it to me to just represent everything with integers? Or, hey, you know what? Records are plenty good for this type of work. Don't go to the effort. It's not going to be worth it. So those are the things that kind of drive my curiosity, is like, okay, what would be the best way to do it? Because there's always a trade-off. So I'm hoping this benchmark is going to end here pretty quickly. And I think it is. Okay, we're on the struct DU. So I believe that's the last test. So when this runs, we're going to get an idea of what the fastest way of representing this job ID is when we want to be able to remove it from a set, which is the scenario that I'm most interested in at the moment. This is not the exciting part, but I think it's almost done. It's really close. Come on. And one of the other things that I would say is the more I have done this, the more I have been surprised about what is fast and what is slow in F#. And also, just because something's great for C# doesn't mean it applies to F#. I think that's another really important thing. It's the idea of trust but verify, like run the benchmark. And it's so easy to create benchmarks to do this kind of testing about, hey, is it approach A or approach B? That, I mean, you've seen what I've done here. I think I'm like 35 minutes in, and I'm going to be able to get some great information out of this about like, hey, what would be the best way for me to do it? So don't take inspiration from the recommendations you see for C#, but be cognizant of the fact it is a different compiler. I'll hope to know the video at some point where I go through the compilation stages of like your F# code and when it finally gets to the CPU. And that is yes, C# and F# are both running on the CLR, but the thing that feeds the CLR is different. And there are special things that happen inside of there. Oh, okay. Fantastic. Happy days. We have results. Good times. So let's look at this. We're seeing, no surprise, integer is really fast. And unit of measure, essentially the same speed. Once you take the standard deviation into account, there's no difference between these. And this is to be expected because the F# compiler erases units of measure. But you still want to test it because there are situations where you have to do some things to work around unit of measure, and that can inject some things that might slow your code down. So again, be aware of that. We see here that, and this continues to surprise me, and I need to reach out to someone on the F# team and say like, hey, please explain this to me, because I'm seeing this again and again when we look at record versus struct record. Record is faster than struct record. This puzzles me because from my understanding, the struct record is going, it's a value type. It should be there in the set. So like once, because the set is an AVL tree. It's a type of AVL tree. And so when it's looking for the value, it's traversing this tree and going through. But when, for any given value, you have the node, and that node, the value in there is a record, it's a reference type. So the actual information regarding the record is going to be somewhere else on the heap. Versus, again, my understanding, a struct record, it's a value type, it should be right there. So my intuition tells me like, well, I'm eliminating a lookup, right? Like this should be faster because I don't have to do this additional memory lookup. But again and again, what I'm seeing is like, no, raw record is raw record. No, ref record, just normal record is again and again faster than using a struct record. I don't know why. I find it very strange. It defies my understanding, but I haven't had time to look into it. Similar story here between DU and struct DU. I would expect DU to be the slowest of all these, like my intuition before running these benchmarks. But again, what I'm seeing is that DU faster than struct DU. And again, this is odd. This is odd. I find this odd. So I want to figure this out. I haven't had time yet. But the takeaway is, okay, this is, again, pretty obvious. If you want to go as fast as possible, it looks like int is the way to go. And it looks like if you're going to annotate it with unit of measure, there's no performance hit. So typically what I do is I say, like the lowest I go is ints with units of measure. I hate just naked ints because it's so easy to lose track of what it's meant to represent. And then from there, man, like record seems to be your next best option, which is surprising. But this is why we benchmark. This is why we test. So this has been fun and exciting. I hope you find this interesting. If you have any other questions that you would like me to investigate, please feel free to reach out to me on Twitter or my email. The link to this code is down in the description. So feel free to go check out the code yourself and run it. You have a great day.